Good morning, everybody. I'm Mike Horton. And today, what I'm going to be talking about is everything you knew about science. Some of it is wrong. I call them science misconceptions. There are other names for them, but they're things that you've known all of your life, and it turns out they're wrong. And there are different places that these come from. Some come from the fact that your science teachers have these same misconceptions. Some come from TV. Some come from misinterpretations of things that you see. But there are lots of misconceptions that we have about science. So a little bit about me. I have a degree in physics from San Diego State University. I taught high school chemistry and physics and computer repair for 10 years, most of that at Paris High School, just up the road. And now I've been the science and the AVID Administrator for the Riverside County Office of Education and the Orange County Department of Education for about 6 years. I'm the author of 2 science books, one of them that just came out last week. And so I've done a lot of research into science, and I love science. It's what I love. I listen to science podcasts in my car. I read science websites when I'm at home. I love science. So, like I said, a science misconception is a scientific fact that you believe to be true, and it's not. For example, one science misconception is that there's a dark side of the moon. There's even an album by that name, The Dark Side of the Moon. There is no dark side of the moon. There is, in fact, a back side of the moon, but it's not dark. It's dark half the month, and it's not dark half the month. When we have a full moon, the backside of the moon is dark. When we have a new moon, the backside of the moon is light. So there is a backside of the moon. There's no dark side of the moon. Another one is that you see this in commercials a lot. It's so hot outside, they cool down their apartment by opening the refrigerator doors. It doesn't work. A refrigerator just takes heat from inside the refrigerator and pumps it outside of the refrigerator through those coils in the back of your refrigerator. And no process is 100% efficient, so opening your refrigerator doors would actually warm up your apartment. It would not cool down your apartment. So those are some examples of science misconceptions. And we're going to be testing some of these today. I'm going to have some volunteers coming up and doing things to test some of the misconceptions that we have about the human body. And I'll warn you, one of them is going to be eating a jalapeno pepper slice. So some of those hands might go down after that. So some misconceptions are completely harmless. They're misconceptions, but they're not going to harm you in any way. For example, there's a huge misconception that oxygenated blood is red and deoxygenated blood is blue. It's completely wrong. There's no such thing as blue blood in the human body. But diagrams like the one up on the screen reinforce this. People have heard it. I've had people in audiences when I'm talking about this stand up and argue with me. There is blue blood. I went to paramedic school and they told us there's blue blood. There is no blue blood in the human body. There's deep red and less deep red, but there's no blue blood. So is that going to change your life? Is that going to hurt you in any way? No, not really, but it's completely wrong. Another one, and this is so widespread, it amazes me, that Mars is red. Mars is not red. Mars is butterscotch yellow. It's not even close to red. And when you see pictures of Mars that are red, like this one, look at the atmosphere of Mars. They had to Photoshop this picture so much to make Mars look red that the atmosphere turned red too. So any picture that you see that has Mars red was highly Photoshopped, and it's usually easy to tell. Mars is really like the color of this floor, like a brown-yellow color. We know the types of rocks that are covering the surface of Mars, limonite, and they are butterscotch yellow. Mars is not red. Is that going to change your life or harm you in any way? No, but it's so widespread, it just blows my mind. Another one, we've probably all had this experience, seen somebody who's let their hair grow until it won't grow any longer. And then they cut it and it grows back. So we think somehow your hair knows how long it is, and when you cut it, it knows to start growing again. It doesn't work that way. Your hair grows for a certain amount of time and it grows at a certain speed. So if it grows an inch a month for 12 months. It'll grow 12 inches long, and then it falls out. But because each one of your hairs started growing at a different time, it's not like every 12 months all of your hair falls out. So what happens is your hair grows to 12 inches and falls out, but you have new hair that's coming, so you don't really notice it. And then when you cut it, all of the hairs that were, let's say you cut it to 10 inches, all the hairs that were less than 10 inches keep growing until they're 12 inches, and then they fall out. So your hair doesn't know when it's been cut. Your hair is not alive. It doesn't have any nerves. It has no idea when you cut it. But it's just that staggering of when your hair started growing that allow it to reach a certain length that it won't get any longer, but then you cut it and it grows back. Is that going to hurt you? No, but it's a huge misconception that your hair knows when it's been cut and it starts growing again. Others are harmful. There are science misconceptions that can hurt you, possibly even kill you. One of them, a sad story that I learned recently, is Steve Jobs. Steve Jobs recently died of cancer. And there was one point in his life when he was diagnosed with cancer, and he decided, I'm not going to go in for normal treatment, surgery or radiation. I'm going to take herbs and change my diet and exercise. He did this for 9 months. And his cancer didn't get any better. Then he went in for surgery. And it's been proposed that he would still be alive today if he hadn't waited 9 months to go in for that surgery. Airborne is a proposed cold remedy that a lot of people take, and they believe that it works. There was a lawsuit that said that the makers of Airborne invented all of the evidence that says that it works. They bought an office building and called it a lab. They paid some fake researchers to make up some fake data that says that it works. It doesn't work. The science has proven Airborne doesn't work. So taking something like this can cause, especially if you're diabetic like myself, or if it's your grandparents and they're older in age and they have the flu and they take something like this instead of going to the doctor, there are a lot of senior citizens who die from the flu. A person could die if they take Airborne instead of going to the doctor to be treated for the flu. The anti-vaccination, the idea that vaccinations cause autism is completely false. 1,000 studies have been done showing there is no link between vaccinations and autism. But there are groups out there, Jenny McCarthy, they've actually calculated how many people Jenny McCarthy has killed by traveling the country and telling people not to get vaccinated. The sad part is, it's usually not the person who didn't get vaccinated who dies. Many people have died from not getting a whooping cough vaccine, but it's not the person who didn't get the vaccine, it's the baby next door. So I don't get the vaccine, I catch whooping cough. The baby next door who's too young to get the vaccine catches whooping cough and dies. It's not me, it's the baby next door. People die because other people don't get vaccines. That's a dangerous misconception. You've probably seen a lot of Major League Baseball pitchers wearing these necklaces that are supposed to make them heal more quickly and have better balance, and they rejuvenate after they're in the lab. Completely 100% misconception. All of the science behind it is completely made up. It's aqua titanium that gives off frequencies that balance the electrical signals in your body. Completely made up. That is rubbish. It's not science. The holographic bracelets, a hologram that's supposed to make you stronger and more powerful. The company that makes these bracelets has a website that says they've done the research and they don't work. The company that makes them says that they don't work, but they accept the $30 million a year that people pay for the bracelets anyhow. And homeopathic remedies. Homeopathic remedy, most people don't know what homeopathic means. It means they take a chemical that may or may not help you with a condition, and they dilute it so many times that there's none of that chemical left in the solution, and they sell you that solution that has none of the active ingredient left in it. Ridiculous, right? Hundreds of millions of dollars a year are spent on homeopathic remedies. People take homeopathic remedies instead of going to doctors, and they get sicker and sicker, and potentially they can die. Another thing that science misconceptions can do is they can lead to pre-scientific thinking, thinking like an ancient Greek person who didn't know anything about science. Ghosts. That's pre-scientific thinking. To think that an object can pass through a wall and then rattle a chain, it's either matter or it's not matter. If it's matter, it can't pass through a wall. If it's not matter, it can't shake a chain. There's no way an object could pass through a wall and then shake a chain or slam a door. That's pre-scientific thinking. Astrology, the idea that an object that's a trillion miles away and its relative position to another object a trillion miles away can affect my personality. And not just that, affect my personality differently than her personality because we were born in different months. That's pre-scientific thinking. Psychics, magnetic bracelets, magnetic cures for diseases have been around since. This is a magnetic comb that was supposed to cure all kinds of diseases. A magnetic device for, there was a whole list of items that this would cure. Here's a magnetic belt that would cure all kinds of intestinal diseases. Another magnetic device. We've been doing this for hundreds of years. We've known that they were fake. And people still spend billions of dollars on magnetic cures. So here's some examples of pre-scientific thinking. The Earth is flat, the sun revolves around the Earth, and global warming is a hoax. Those are all pre-scientific thinking. Misconceptions also block you from learning the correct concept. There's some videos out there, and they're really good videos. They're called Minds of Our Own and Private Universe. They're free online. And they take people who have misconceptions and try to break those misconceptions and show how hard it is. There's a boy that they put an apple on a table, and they say, if we turned off all the lights in here, what would that apple look like? He said, well, it wouldn't be red anymore. It would be gray. So he has the misconception that we can see in complete darkness. So they did it. They sealed off the room with duct tape, and they turned off all the lights, and they said, what do you see? I don't see anything. Give me some time for my eyes to adjust. 5 minutes later. What do you see now? My eyes still haven't adjusted to the darkness. 10 minutes later. What do you see now? I still can't see it. So they flip the lights on and say, what did you learn? He said, I learned it takes a really long time for my eyes to adjust to the darkness. And they asked him, where'd you get this idea that you can see in the dark? And he said, I was walking around the house one time with a flashlight, and I shined it on my cats, and his eyes glowed back at me. So our eyes send out light beams that bounce off of things, and they come back to us, and we can see in the dark. That one experience in his life kept him from understanding that we cannot see in the dark. There's a huge misconception that the seasons are caused by the elliptical shape of the Earth's orbit. When we're closer to the sun, it's summer. When we're farther from the sun, it's winter. Then how could it be summer in the northern hemisphere and winter in the southern hemisphere? How can half the Earth be close to the sun and half the Earth be far from the sun? It doesn't even make sense. Not only that, but let's talk about the shape of the Earth's orbit. Look at these 4 pictures and tell me which one of these do you think is the same shape as the Earth's orbit. So raise your hand if you think A is the shape of the Earth's orbit. B? Okay, a lot of hands for B. C? A few hands for C. D? 1 or 2 for D. Turns out the correct answer is D. The Earth's orbit within 99.97% is a perfect circle. It is so perfect, if we drew it up on the screen, you could not tell it from a perfect circle. In fact, here it is. 5 of these are perfect circles, and 1 of them is squashed 10 times more than the Earth's orbit. Can you figure out which one? Call it out. I heard B's and C's. Turns out it's B. 10 times more squash than the Earth's orbit is. The diameter of the Earth this way is 12,756 kilometers. This way, 12,713. If a basketball were squashed that much, it would be squashed less than a millimeter, less than this much, and you would not be able to see that. The Earth's orbit is nearly a perfect circle. So here's another misconception, and here's where I need 2 volunteers. that hot peppers give off heat. I hear people say, I ate a hot pepper so hot it gave me blisters in my mouth. So we're going to test that. I have a thermometer that you can just point in your mouth, and it tells you how my mouth is 82.5 degrees. I took it away too fast. 91.3 degrees. So we'll find the temperature of someone's mouth before and the temperature after. So first what we need to decide, though, is how much of a temperature change would it take to cause pain? 1 degree, 2 degrees? If I turn the temperature in this room up 2 degrees, would you go, ow, ow, it's hot in here, that hurts? How much would the temperature have to go up before it hurt as much as a hot pepper in your mouth? 200 degrees? Does everybody think that's pretty reasonable? So hundreds of degrees, right? If it goes up 1 degree, that might just be from the chewing process. So hundreds of degrees is what it would take to cause pain. So if it doesn't go up hundreds of degrees, then we can say it doesn't cause heat. So who wants to try a slice of jalapeno? Come on up. Okay, so what's your name? Alfredo. I'm going to measure the temperature of his mouth before. Go ahead. 90.8 degrees. Now go ahead, pull one of those out of there. Chew it up and tell me when you're ready. I'll test the temperature again. Is it getting warm? Okay, you ready? Let's try it again. 89.3. Go get some cold drink. So do hot peppers cause heat that could blister your mouth? No. In fact, they removed some of the blood from his mouth and actually made it a little bit cooler. It's actually a nerve sensation. It numbs some nerves that make your brain think that your mouth is hot, where there is no actual heat. That's not the remote. I'm going to talk about this one quickly because I'm running out of time. You're taught that the primary colors are red, yellow, and blue. There are 2 sets of primary colors. Neither of them are red, yellow, and blue. For additive colors like this projector, the light, the primary colors are red, green, and blue. And for subtractive colors like pigments, like your shirt and printing color pictures, the primary colors are cyan, magenta, and yellow. If you've ever refilled an ink cartridge in an inkjet printer, the 3 colors you refill are cyan, magenta, and yellow. When you plug a laptop into a projector, you plug it into the RGB port, the red, green, blue port. But 99% of the world thinks that the primary colors are red, yellow, and blue. So last one, and I'm going to need a couple of volunteers for this one. We think that there's a map of taste buds on our tongue, and certain parts of the tongue can taste certain things. So here and here, you guys are up close. So what I'm going to ask them to do is I have 2 bags of white crystals. One of them is salt, one of them is sugar. And the tip of our tongue, according to this map, should only be able to taste sweet. They don't know which one is which. So I'm going to ask them both to dip a Q-tip in one of these substances and touch it to the tip of their tongue and see if they can taste it. If this is true, only the sugar person will be able to taste it. If it's not true, they'll both be able to taste it. So here's some water to wet the Q-tips. Yeah, hold on to that. There's a Q-tip. Go ahead, wet the tip of that so the crystals will stick to it. All right, you try this one. Go ahead, just touch it to the tip of your tongue and tell us what you taste. You try that one.
That's sweet.
Okay, so his tastes a little bit sour. Would you say it tastes salty or sugary? It tastes salty. So they both, his tastes sugary, his tastes salty. They both touched it to the tip of their tongue. Is this true? No, according to this diagram, salty is on the sides of the tongue and sweet is in the front. It turns out, thank you both. Thank you. It turns out they found the German document that originally was mistranslated and led to this diagram. And for hundreds of years, we've believed it. Knowing, anybody who's ever done something like that knows it's not true, but it's in every scholastic science book that you buy. It's on thousands of websites, and it's completely false. So what can you do to prevent science misconceptions? First, stay skeptical. When you hear something that sounds too good to be true or difficult to believe, don't believe it. Take biology, chemistry, and physics. There are misconceptions in all three of these areas, and if you just take biology and chemistry, you'll have physics misconceptions. If you just take biology and physics, you'll have chemistry misconceptions. Go to college, where you'll learn about sciences. There are social studies misconceptions, there are math misconceptions, there are all different kinds of misconceptions. So continue your education in college and do your research. Don't ever believe anything you hear, see, read on the internet. Go out and do the research to find out if it's true or not. So keep those things in mind, and that'll help you stop from getting science misconceptions.